We are having the third concept, that is next is examining significance of independent variables or significance of predictors. Let me explain this concept using bivariate regression first. Suppose we have this model. This is y is equal to beta 0 plus beta 1 x1. Right? So if we compare this with the with the line equation that we have done in the coordinate geometry, so if it is compared with y is equal to mx plus c, c is equivalent to beta 0 and m is equivalent to beta 1. So this beta 1, which is known as regression coefficient of y on x1, right? So this regression coefficient is equivalent to slope, right, which is equivalent to m. Right? Slope is actually delta y over delta x1, means it gives rate of change in y with respect to x1. Means if we make unit change in x1, then what would be the change in y? It is being measured by the beta 1 or the regression coefficient, right? So if beta 1 is 0, beta 1 0 means delta y would be 0, means on changing x1 there won't be any change in y. So if this is the case, then we can say that our regression model is insignificant, right? So this is the case for the bivariate regression. Let us generalize the case, means we can have y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 up to beta 6 x6 and so on. So these regression coefficients are now known as partial regression coefficient. They are known as partial regression coefficient. Here we have used the term regression coefficient, but here I am using partial regression coefficient. So why we have used only the term regression coefficient? Because here we are having a single independent variable, single predictor. So we are concerned with x1 only. But since when we are explaining x1 part, means that is beta 1, then we are having more, apart from x1, we have other variables like x2, x3, x4, x6 also. So this is known as partial regression coefficient of y on x1. It means rate of change in y, right, just like the bivariate case, with respect to x1, provided, this is the catch, provided all other independent variables, all other independent variables means x2, x3, x4 up to x6 remains constant, right? So that was not required in the bivariate case because we are having a single variable. But here we are having other variables also. So beta 1 is known as partial regression coefficient of y on x1, which gives rate of change in y with respect to x1, provided all other independent variables x2, x3, x4, x5, x6 remains constant. In the same manner, beta 2 can be interpreted as partial regression coefficient of y on x2, means rate of change in y with respect to x2, provided all other independent variables are x1, x3, x4, x5, x6 remains constant, right? So this is the concept. Now, as we have discussed, if beta is 0, right? So we would check the significance of the independent variable or significance of the beta by proposing hypothesis as h naught is beta equals to 0. Beta equals to 0 means insignificant partial regression coefficient. So if this is insignificant beta means the relationship of that predictor with y is insignificant, that is having no impact. And if h1 is obviously opposite to h naught, so this is beta is not equals to 0. So we perform this beta testing using t-test for all the regression coefficients, right? Right? And if we have a p-value or significance, that is the p-value or significance is small, less than the default value 5%, then we can say that we are rejecting H naught at 5%, means we are rejecting the insignificance of beta, means beta is not equals to 0. So we can say that the considered predictor is significant in nature. So we will simply look for all those predictors which are having p-value or significance less than 0.05, then they all are taken to be significant. Okay. So let me have one more slide. I am sharing the output. So now we are considering this table, right? Here we have predictors, constant departmental identity, and so on. So if we consider the p-values, these are the p-values, right, of these beta. Beta are the standardized coefficient, right? So let us check what are the significant predictors. Constant is significant. Departmental constant means simply the interceptor. Departmental identity is significant, having p-value 0.000 less than 0.05. Then we have youthfulness as significant. So the first significant predictor is departmental identity less than 0.05. Youthfulness is again significant, less than 0.05. Emotional connect is again having p-value 0.00. This is less than 0.05. So we have three significant predictors: departmental identity number 1, youthfulness number 2, and emotional connect number 3. So let us remember the three significant predictors as departmental identity, next is youthfulness, and next is emotional connect. So let us write the significant predictors as, the first one is departmental identity, DI, because its p-value is 0.000 less than 0.05. So this is significant. The next is youthfulness, right? Here again the p-value is less than 0.05, so it is significant. Then third one is emotional connect. Here the p-value is again 0.000 less than 0.05. So they are the significant predictors, or they are the significant independent variables. Means these variables, departmental identity, youthfulness, and emotional connect, are having impact on the likeliness of the rebranded logo. Right? Let us check these values again. The significant predictors are departmental identity having p-value less than 0.05. Youthfulness is again significant, having value less than 0.05. And emotional connect is again having p-value of significance 0.00 less than 0.05. So they are the significant predictors. Right? They are the significant predictors. Now we will try, since we have three significant predictors, so we will try to create hierarchy of significant predictors, because only significant predictors are important for us. So we will try to have hierarchy of significant predictors or hierarchy of significant independent variables. We will consider these three things. Now let us introduce two type of regression coefficient. One is B. B is known as unstandardized regression coefficient, right? Unstandardized regression coefficient means it is affected by scale and unit of measurement, right? So if different variables are having different scales or unit of measurement, then this value of B got affected. Okay, this is known as unstandardized. We have one more regression coefficient, that is beta. Beta is known as standardized regression coefficient. This standardized regression coefficient is free from unit and scale of measurement. Unit of measurement means it doesn't matter whether you are using the same scale or not. It is not affected. So obviously, since B can be affected by unit and scale of measurement, let me have an example. Suppose we have three variables which are significant. Suppose they are x1, x2, x3. All are having same B. All are having same value of B, and these values are 5, 5, 5. Suppose the first one is measured on a scale of 1 to 5. Second is measured on a scale of 1 to 10. Third is being measured on a scale of 1 to 100. So if we observe only the value of 5 and try to create hierarchy as per the unstandardized coefficient only, then we will get the impression that all three are equal. But it is not the case. Since it is on a scale of 1, 5, so this can be actually very high among the top, since it is coming on the top. This 5 is lying in between, so this is having a moderate impact if we consider the scale also. And if we have the third, it is on the lower side. So now we can say that this x1 is highly important, x2 is not so, and x3. So that's why we always create hierarchy using beta value, right? So we will create hierarchy using beta value or standardized value. So we will consider the standardized value of these predictors. So let me have the output. So the standardized value of departmental identity, or beta, as you are observing, the standardized coefficient beta for the departmental identity is 0.285. So let me write the value, 0.8285. So it is having beta as this is significance, this is beta. Here the value for beta for departmental identity is 0.285. So now again the second value. Next significant predictor is youthfulness. It is having the beta as 0.312. So we are having next value as 0.312. So we are having beta as 0.312. And the third one is emotional connect. So let we have the output again. So here for emotional connect, beta comes out to be 0.399. This is the third value, 0.399. So we are having this value as 0.399. So as you observe, this is at number 1, this is at number 2, and this is at number 3. So the most important predictor or independent variable having impact on the willingness is emotional connect. Means the logo must have the impression for the emotional connect. This emotional connect should be taken with the highest importance. The second being youthfulness. The logo must be giving an impression of youthfulness or the vibrant thing. And third one is the departmental identity. They also show that it is belongs to a police department. So this is related to hierarchy of the significant predictors. So let me show you, just to check, let me show you this output again. So we compare only the standardized beta, right? So, okay. So this is the concept related to hierarchy of the significant predictors.